Good morning, SEP101. Matt here. Today we're going to learn how to use the actual Arduino in Tinkercad. So what I've done here, go ahead and log into Tinkercad and make sure you go to, usually it starts with 3D Designs, make sure you go to Circuits. We're going to click Create New Circuit, okay? And once you get a blank new circuit, we want to pull out two things. Search for Arduino, ARD, usually it'll just come right up. And it's this little blue thing here. Looks like a little microcomputer or a microchip or something. And we also want a breadboard. So I'm going to search for breadboard, grab that. And I'm going to flip both of these. So I'm going to click on it and press my R key so that it's vertical like this. And I'm going to click on the breadboard. I'm going to flip the breadboard too. So it's up and down. I can read the letters and numbers a little easier. And you notice on the Arduino it has a simulation of a USB cable. And in real life this cable plugs in here and the Arduino gets power. So at first we're going to think of this Arduino as a battery. We don't need a battery anymore because the Arduino supplies power to our board. And here's where we usually grab power from. All these black lines on the edge of the blue Arduino, we call these pins, and they all go to different things. We're going to learn about them as we go, but first, in this section right here, we have some things that we, reset this thing, IO ref, I don't know what that is, but we've got 3.3 V, that's 3.3 volts. We have 5 volts, and then we have G and D, and these are grounds. So these function as a negative and positive terminal on a battery. So the first thing I'm going to do is I'm going to grab the 5V. I'm going to click here and bring a wire from 5V over to the positive rail. Now one thing you might have noticed, if you click before you actually make that connection, you can do kind of fancy things, like you can bring your wire up here and kind of move it around like this. I might do that just for fun. So now I have a wire going here, and I'm going to make this a red wire because it's my power. Now I'm going to take, you don't have to do this curve, you can go straight over. From one of these G and D's, it doesn't matter which one, I'm going to go from here, and I'm going to go to the negative rail and plug in there. And that's going to be a black wire, just to remind me that this is my positive charge, this is my negative charge, and now I've created a circuit. Now I can use these rails to make an actual circuit happen. And let's do that. We'll do that with an LED. So I'll take my LED out, trusty LED, and a resistor. Let's get a resistor out. And the first thing I'm going to do is I'm going to bring a negative charge. I'm going to jump that out here from the rail, from the negative rail where I have the black wire going to ground. I'm going to bring a wire out here. And in this row, now we've got the breadboard flipped, so it goes across here. I'm going to plug my resistor so that the top part of my resistor is touching somewhere in the same row as this black wire here. So they're in the same row. That means current is traveling through this black wire, down through the rail, into this wire, and into this resistor. And now down into this row, row 7 down here. It's jumping from row 3 to row 7. From row 7, I'm going to bring a wire to the cathode of my LED. And from the anode of the LED, and now I might get fancy and start doing some of this curvy line stuff here, I'm going to jump down to another row. And that's going to be a red wire because now at this point, we've run through the LED and now we're at the anode, which wants positive charge. And now from 13, anywhere in this row, you could have gone to any row here, but in the same row, I'm going to jump over to the positive. Now the default resistor is 1 kilo ohm. And we've usually been changing that to 40 ohms on our 3 volt circuit. Now if I run this, I get the error, it's too much current. Well, that's because we used to be using a coin cell battery, and that's 3.3 volts. Now we're using 5 volts from the Arduino. We could use 3.3 volts, and this would be fine. But let's get this closer to real life and how we would be working in the classroom. We would be using, I'm going to click on my resistor, a 330 ohm resistor. Now remember, I changed this from kilo ohms to ohms. 330 ohm resistor. Now if I run it, my LED works perfectly. Now you might be wondering, why do we go through all this trouble and bring this giant board out here just to make an LED light up? Well, where we're going to be going with this is we're basically, from here on, we're going to be coding our LED and flashing some code into this chip here. And it's going to do different things. We can cause the LED to blink at different intervals. We can have the LED react to how close something is to it, or how much light is in the room, or if there's sound happening, the light can light up. And we do that by pressing code, and we can manipulate code, and these are block codes just like Scratch. We can also use text-based code, and that's what this is. And this is actually C++, which is a new language we're going to be learning to code this Arduino. So I did that by doing blocks plus text, so I can see this is the regular code version of what these blocks are doing right here, which is kind of cool. We can see what the actual code would look like if we're using blocks. So I'm going to close the code window. I wanted to just start this basic setup in this build right here, and we're going to use this build on Wednesday to start to change some things and use some code and see what this Arduino can do. We're going to use this same project. So now the last thing I want you to do is rename your project. We're going to call this Arduino Circuit number 1, or #1. Arduino Circuit 1. That's what I want you to name it. And then when you're ready to turn it in, remember, click Share, scroll down, click Invite People, copy this link, and turn this link in on Classroom. Again, that's clicking the Share button up here, invite people, copy the link, and share that on Classroom. And remember to save it as Arduino Circuit 1, because we're going to come back to this on Wednesday and build some more things to see what this board can actually do. All right, until next time, see ya.